Right, so I'm just going to work through these P5.3 power questions with you. So there's two ways you can go about doing this. If you want to have a really good go yourself, then you can do it, watch my video and then mark it yourself. And then remember, we're looking for fluency in the topic, which means you'll really understand the topic. We're looking for 80%, okay? Some of you are like, this is a bit tough, so I really want to do some work with you. So why don't you do a bit of both? So you watch me do a few questions and how I model it, and then you have a go yourself. And those of you who really just want that peace of mind, just work through it with me, but make sure you understand everything. And anything you don't understand, just highlight it in red and we'll tell me and we'll go through it together. So we're looking at the equations. So let's remember, we've got PET, we've got PIV, we've got, I don't know how to say it, PIR, but I squared R. We've got VIR, VIR, and then there's one more, which I'm going to forget now. Oh, quit. So I've just quickly drawn all my triangles. Worth you popping them down on a index card or something and just learning them. Just remember the PET one, all the others, PIV, PIR, VIR, quit. But this one, PET, just sort of goes the other way around. So you might want to remember is EPT. Okay. Let's question one. Diagram shows a circuit used to obtain data needed to plot a current potential different graphs for a filament bulb. Why is a component labelled J in the circuit? This is a hard question for you because we have power packs which contain one of these. This is a variable resistor. So when we did this practical, we didn't have a variable resistor because it's already in the power supply. But this is just a battery, so it can't change the voltage on it like the power packs. So J will change the potential difference, which is voltage, across the bulb. Okay. The resistance of the bulb as the increases as the potential difference increases. Why is this? Because there is an increase in current which increases temperature, which increases the vibration of the fixed ions. Okay, so this is only worth 1 mark, so you wouldn't have to write all of this. I think you just need to say it increases the temperature. But yeah, that's a good answer, like a 3-mark answer. So I would write it all because you're going to the exam and yeah, I know what I'm talking about here. Right, the bulb is at full brightness when the potential difference is 12 volts. The current through it is 3 amps. So here's what I would do as I'm reading the question. I've written my things at the side. Calculate the power of the bulb. So I've got V, I, and I want P. So I go back to my little triangles and I'm like, oh, which one's got P, I, and V in? Oh, it's this one, PIV. So P equals I, V. I times V. So I've got 12 times 3, okay, which is 36. So that's your answer. Okay, now question B. In this question, be assessed on good English, organising information, blah, blah, blah. So basically, in science, that means that you put everything in order and you spell key terms correctly. So if we have a look here, we've got loads of information and we're going to write about it. So the first thing it says is evaluate the cost and efficiency. So let's look at the cost. The first point you could make here is the halogen is cheaper. Okay, the halogen is cheaper. However, the light emitting diode lasts longer. So what we can do is figure out how much longer. So if we do 36,000 divided by 2,000, it gives us 18. So that means you need 18 halogen. You'll have to write the word halogen Hi, so I'm having a little bit of a problem with my visualizer today because it's not recording properly. So I'm recording this at the end, but I've had to go back to my answer. Nightmare. Anyway, and you'll see later in the video I make another mistake. But here we go. So what we got to was here, 18 times longer. So you need 18 halogen lights for one LED. The cost of that is 18 times £1.95, which is £35.10. So in the lifetime of one LED, it's actually cheaper to buy the LED than 18 halogen lights. In terms of efficiency, the LED is, and you can figure out the values here, 32% divided by 10%, so that's 3 times more efficient. So you get to waste less energy. And then I've gone on to this question, and hopefully I should be explaining the answers in the next section of the video. Right, I'm not sure what happened there. My visualizer stopped working, so I'm not sure what you got. It says, what colour is the insulation around the wire connected to the live? It's brown, because if you touch it, you poop yourself. And what does a hairdryer not need an earth wire? It's because it's made of plastic. Okay, if it was made of metal, then if the live wire was to touch it, then you could get an electric shock. And the question says, all the switches are in the off position. Which switch have to be on to make only the fan work? So the fan is only connected to switch 1, so that's S1. Only heater 2 to work, you need S3, but you also need S1 to work because that's connecting the whole circuit. And says heaters can only be switched on when the fan is also switched on. Explain why. It's because because you need switch S1 on to turn the fan on, and if that's not switched on, nothing will work. Okay? Okay. So S1 is switched on to turn the fan off. Then it says, table shows the current drawn from a 230 volt mains electricity supply. Calculate the maximum power of the hairdryer. So we've got PIV, and the maximum power will be the voltage and the highest current, which is this one. So P equals IV, which is 6.5 amps times 230 volts. Is 1495, which is basically 1,500. Give the unit watts. It's a W there. Okay, question 3. A homeowner has installed an electric underfloor heating in the kitchen. When the heating is switched on, the electric current flows through the wires under the tiled floor surface. What is electric current? So in a wire, in anything, electric current is the flow of charge. In a wire, that's negative electrons. The graph shows how the power output of underfloor heating system depends on the floor that's being heated. So you've got some information here. So we've got V is 230 volts and I is 10 amps. What equation shows the relationship between power, current and voltage? So we've got PIV, so power equals current times potential difference. Actually it should be, in your exam it will be potential difference. This is an old exam question, but remember potential difference is the same as voltage. Give the power of your heater. So we're going to do 230 times 10, which is 2,300. So I've just used this equation I've just written down to calculate that. It says what rating in the fuse should be used in the immersion heater. Well, the current is 10 amps, so you don't want to use a 10 amp fuse. I would probably say use a 13 amp fuse. The exam answer says a 15 amp fuse or allow 13 amps. I mean, I think 13 amps is better because it's a bit closer to 10 amps, but they might think that's not enough margin of error, which is why they've said 15, but either answer is fine. And it says there are 3 wires in the cable to the immersion heater. I think actually I've done the wrong question here, haven't I? Sugar. Let me finish this question off and I'll go back. I've missed the graph question. You're all probably thinking, what's she going on about? Oh well. Right. So there are 3 wires in the cable to the immersion heater. 2 of the wires are connected to the immersion heater. The 3rd wire is connected to the copper tank. Explain the function of this wire and the fuse. So the earth wire, okay, takes current to earth if live wire touches metal tank, and the fuse brick melts if the current is too high. What is the equation which shows the relationship between resistance, current and voltage? That should be potential difference. So it's this one there. So potential difference equals current times resistance. Calculate the resistance of the heater. So R is V divided by I. So that's 230 divided by 10, which is 23. And give the unit, ohms. Right, let me go back and do question 3 that I didn't do. So we're looking at this graph. Sorry about that. It says the area under the homeowner's kitchen is 9 metres squared. Calculate using the graph the current drawn. Using the graph. So 9 metres squared, you will use a ruler and count it properly, but you go up and across. And it says here the power, when you measure it across, is 1.6, but look, kilowatts. So power is 1.6 kilowatts, which is 1,600. It tells you that its main supply, so the potential difference is 230 volts. We want to find current. So we go back to our triangle. PIV, current, is power divided by potential difference. So we're going to do 1,600 over 230, which is 6.956521739, which I'm going to round up to be 7.0 amps. Give the unit. I'm looking for you to get 80% fluency on this. So, if you did it yourself, add up what you got, get a percentage. 80% fluency shows you really understand what has gone on in this question, these questions. If you haven't quite got 80%, have another go at them, print them off, do them until you get 80%. The more you do them, the better you'll get, especially if you really struggled with them in the first place. Okay, hope this video is helpful. I'm sorry about the confusion with the questions.